All right, hello guys. Today we're going to be going over 1.3. It's the last section in chapter 1. Hard to believe we are already through the first chapter, but we're moving along. Hopefully it hasn't been too bad for you. I know stats is a huge adjustment. It's weird, it's different, it's wordy, but I hope you're liking it so far. I love it. I hope you do too. So without further ado, let's jump into 1.3. 1.3 is probably the most dense section that we're going to learn in chapter 1. There's a lot of different parts to it. I'm going to be doing some book stuff, so if you see me walking back and forth, I'm going to be reading a couple things from the book to you. But we'll go from there. Okay, so what is 1.3 all about? 1.3 is the introduction to an experimental design. So if you think back to our definition of stats, right? We're collecting data, organizing it, we're then interpreting and analyzing it, or we're analyzing and then interpreting. In that collection data stage, we are going to talk about the design of an experiment. So we talked in 1.1 about the different parts, the variables, the objects, quantitative, qualitative, all that. 1.2, we looked at how do we get a simple random sample, and now we're kind of going to throw some pieces together, the different parts of an experiment. Okay? So again, reviewing the process of a statistical study, how does this relate to science experiments? I'm not going to really write anything for this. I just hope you think back to 1.1 when we looked at the definition and said, okay, we're going to identify an object. And then from there, we're going to look at a variable. And then we're going to manipulate that variable. And we're going to study how it reacts. And then from there, you know what? We gather our data from that study, and then we collect it, we organize it, we analyze it, and then we interpret it. It's very similar to the scientific method, and I hope you're seeing those parallels. So the first new term of today that we're going to talk about is a census. And the question becomes, what is a census? Well, your definition for a census would be a measurement from the entire population. A measurement from the entire population. Okay? So we talked a ton about samples in 1.2, but the question becomes, what if we don't want to use a sample? Your best data actually comes, and your most accurate data can often come from looking at the whole population, if it's feasible, right? So the challenge and kind of the play back and forth here is, while there's a lot of steps in going through a survey to make sure it's accurate, surveys are still often easier than taking measurements of the whole population. The problems you can imagine is cost, time. How do we actually reach everyone? If you don't believe me, look up all the hassle in the US government doing a census every 10 years. Again, I'm not saying it's bad. I'm just saying it takes a lot of work. So sometimes it's not feasible, and that's when samples come into play to do a census. But when we can, it can be very accurate. It will more accurately represent the population than obviously a biased sample, and then sometimes even a good sample, because you're looking at the whole population. So the measurement from an entire population, that's a census. Okay, again, how is it different from a sample? We're looking at the whole population. So now let's get into, we've talked about census, so that kind of plays against samples and experimental designs. Again, experimental designers have to make all these choices, so they would choose between a census and a sample. They also have to choose between an observational study and an experiment. And what is the difference? We kind of throw the word experiment out all over the place. But really, what's the difference here? So let's talk about it. Okay? An observational study. An observational study, observations and measurements of individuals are conducted in a way that does not change the response of the variable being measured. Again, this is a great time to pause this video and write down this definition. I'm not going to ask you to regurgitate it, but you need to know what it means. So go ahead and pause it. Okay, you've written it down. Here's the big key. Does not change the response or the variable being measured. What are some examples here? Scientists studying ocean patterns. Are they impacting the ocean? No. Scientists looking at melting glaciers. Someone studying someone's eating habits, a nutritionist maybe that first week, where they're just seeing how someone's eating. All of these are examples of observational studies. They are observing the behavior of the individual or the objects without impacting it. An experimental study, on the other hand, is a treatment deliberately imposed on the individuals in order to observe a possible change in the response. The deliberately imposed change. We are trying to impact our subject's behavior, whether it's a person or a thing. Think about fields, farming fields, when they put special chemicals on a section of crops to see if they impact the growth or the health of the crop. That's an experiment. The chemical is that deliberately imposed treatment, and we're trying to see a change, not just observing how the crops are growing. As opposed to a nutritionist just watching someone's eating habits, having them do special workouts to lose weight would be deliberately imposing a change. Again, that would be classified as an experimental study. Okay? If you want some extra practice, think of a topic on your own. Something that relates to you, whether it's music, video games, you live in a rural community, so maybe you want to do something with farming, I don't know. Whatever you're into, pick a topic and create an observational study and an experiment and look at the key differences. If you aren't unsure after you do this, if your answers are correct, shoot me an email and I can check your work. But this is just an option. Again, if you want to really get this down in your brain, come up with your own example. All right. So now we're going to talk about some big keys to know for experiments. We contrasted experiments and observational studies. Now we're going to hone our gaze on the experiment. Okay? So we know an experiment is a deliberately imposed treatment trying to impact change. The question becomes, what's the control, right? So in an observational study, we're just seeing what happens. But in the crop example, right, I'm impacting a certain group of crops. Well, how will I know if there is a change? I'm trying to make a change happen, but how do I know if it occurs? I compare it to the control. The control, sorry, I lost my place. The control is going to be that thing that we don't change. No change group. Okay? Again, you're probably familiar with this. Whenever you've done an experiment in science, you typically will have a control, right? Something, so if I'm doing special chemicals on crops to impact change, well then what I'm doing is I'm letting some crops just grow normally as they have been. And then I'm going to see which are taller, right? That'll let me know if my change was beneficial or not. So the control, the group that isn't changing. Another thing to think about is there a placebo effect? Okay, now placebo effect is very specialized. If you watch Grey's Anatomy or some other medical show, you probably know what the placebo effect is. We see it a ton in medical studies. Not really any studies out that don't have to do with human beings. You don't see this, but you do see this with a lot of studies with humans. So what is it, Mr. Carter? Well, placebo effect is when an individual improves because they think they are being treated. This actually has to go do right with a control. So you improve because they, and you're going to see me box this word, think they are being treated. You see this a ton in medical studies, right? Say I have, let's do, I'll give an example with lasers here, okay? So I'm going to give an example with lasers. Your book has this in it. So a great example, since 1980, surgeons have been using a laser procedure to drill holes in the heart, and many patients report a lasting and dramatic decrease in their chest pain. So these individuals have chest pain, right? And so to get rid of the chest pain, they take this laser and drill these tiny holes in your heart, and it actually relieves the chest pain, okay? But some scientists and medical examiners were concerned that this was due to the quote unquote placebo effect, not the actual procedure of the little holes being drilled in the heart. They were worried that the individuals were improving because they thought they were being treated. So what did they do? Well, they got 298 volunteers who have this severe chest pain. And then what they did is they divided them into two groups. One group of 149 patients actually had the procedure, the tiny holes drilled in their heart. The other group thought they were being treated. They were sedated, but they were left, they could still hear. In both cases, they were sedated. The procedure happens, but they could still hear. And they had the laser machine going. They looked like the doctors were doing this procedure to these people, but it didn't actually happen. They didn't have the holes physically drilled in their heart. They just replicated the experience. So what was the result? Well, the people with the laser holes drilled in their heart actually reported improvement. But what was crazy is the people who didn't, who just thought they had it, also reported improvement. And as a result, scientists and other medical experts really dug into and studied further the laser procedure. So what's the point of that story? Placebo effect is improving because you think you are being treated, not because you actually are. And often in medical studies with pharmaceuticals and drugs, we often will run a treatment like I described. It's called a randomized 2 treatment experiment, so that we account for the placebo effect. Because we don't want to come out and say this new drug or this new procedure is awesome when really individuals just got better because the mind's a powerful thing and they thought they were getting better. So that's what placebo effect. What is a double-blind experiment? A double-blind experiment is when no one knows what's going on. Not no one, but a third party is really in control. So you can think of this as two groups of people, right? There are the people conducting the experiment, and then there are the people receiving the treatment, okay? But a double-blind experiment, a third party would be running it, and even the experimenters who wanted to do this study won't know which group is the control, and they won't know which group is actually getting the treatment. Your formalized definition you could think of is neither the experimenter nor the individual in the study know if they are the control or know which group is the control. And which is being treated. Again, a lot of times we see this in the medical field, right? So again, you could imagine this with pharmaceutical companies. If I'm a pharmaceutical developer, I've developed this drug and I've come to the testing stage. I really want it to work, right? Maybe I'm good-natured and I really want this to help people, or maybe I'm financially motivated. I want to get a big payday and this to pay off. And so what I would do to limit my bias is I would run a double blind. I would have a third-party group come in and run the experiment so I don't bias the experiment by favoring the treatment group. Or this also could help the placebo effect somewhat. So that's a double-blind experiment. And then what is a randomized 2 treatment experiment? A randomized 2 treatment experiment is what I described, excuse me, with the laser example, okay? That is when we randomly assign people to groups and both think they are getting treated being treated, and we compare the results. Again, this goes hand in hand with the placebo effect, right? The placebo effect could be a consequence of a randomized 2 treatment experiment. Think of the laser example, right? Some people were assigned to the getting holes drilled in heart, think they're getting holes drilled in heart groups. We run the experiment with 2 different groups. They both thought they were getting the actual treatment, and then we compare the results and look for the placebo effect. Okay? So those are examples of, or those are the definitions and specifics of experiments that we want to know. Pages 22 and 23 are really good examples. They're really good at explaining this. Again, if you're sitting here like, oh my gosh, Mr. Carter, you just rambled for like 15 minutes. I have no idea what's going on. Those are really dense. That's okay. Look at page 22 and 23. Also, this is a great time to pause the video, email me any questions you have, or say, hey, Mr. Carter, you blabbered on about placebo effect for 10 minutes. Can you give me the concise definition? And I will happily do that. Okay? So that's experiments. And now we'll jump over to the second part of the lesson. Now we're really going to get into some application here. Okay? So let's apply what we've talked about. To apply this, great, Mr. Carter, I learned all these definitions. What do I actually need to know? Sorry, I'm going to move this camera here. What do I actually need to know? Well, we want to determine which technique for gathering data should be used in the following circumstances, okay? We've talked about all these different things of gathering data in chapter 1. When do I use what? Okay? So let's talk through this together. Here on the left, I've got 4 different types of collecting data. Here on the right, I've got 4 different situations. Take a second, pause the video, write these down, and see if you can figure out which definition or situation should go with which type of data collection. Okay, now that you've paused it, what I want you to do is I want you to check your answers with mine. So we're studying the effect of stopping the cooling process of a nuclear reactor. Please tell me that you went with simulation here. If you run an experiment and it goes wrong, we've got radioactive material everywhere. Simulation, nuclear reactor, right? Dangerous situation. Let's run a math simulation of it before we ever get into experimenting with it. A study of the credit hour loads of each student enrolled at Van Buren. Okay? Study of the credit hour loads of each student enrolled at Van Buren. Well, the key word here is each, right? I want to study every student. So to me, that screams census. Okay? I want to do a census here because I'm looking at the whole population, every student at Van Buren. All right, a sample, study of the amount of time a college student watches TV. Study of the amount of time a college student watches TV. This is something that I could do a sample for, right? I could maybe pull 100 different individuals. Again, I'd use a simple random sample or something of that nature, but I could pull the University of Findlay and still get pretty accurate results of the TV watching time. You know, it's not something dangerous like a nuclear reactor. I don't need to interview every student like I want to do in the credit hour load. So a sample would be sufficient here. And then the study of the effect of a calcium supplement given to young girls on bone mass. running a sample, like a sample survey here, really probably wouldn't be ideal. I need to do I really want to do an experiment, right? A survey is not going to work here. Running an experiment, though, again, probably not going to use every young girl that's ever existed. There will be some sort of sampling here, but we definitely want to run the experiment if we're going to study this effect. We want to do it scientifically and be accurate. It's not something you could accomplish with a survey. So hopefully you got those right. If you do have questions on those, obviously let me know. I will be happy to help you. Okay, let's talk for a second about the problems of surveying people. So you've kind of seen two different paths here, right? You're probably thinking back to 1.2 when we looked at simple random samples and how we talked, frankly, a lot about surveys. And then you hear this stuff with experiments. So let's go back and kind of look at the 1.2 stuff and go, why would we struggle to survey people? I know you already heard some different types of sampling that were kind of skewed, but what are some problems that can present themselves? Well, one of the problems with surveying people is going to be bias. Okay? If you survey people, bias is always going to be present, right? And this could come in varying degrees, right? If you're going to survey me about I don't know, let's give a good example here. Survey me about whether we should pass the levy or not. Okay, great example. Survey me about passing the levy or not. I am probably going to be biased because of my occupation. I'm a teacher, right? I'm going to be very biased toward whether we should or should not pass the levy because it affects my salary. Whereas interviewing someone in the community might be less biased. Or maybe they had a bad experience with the school, and that's going to bias them to vote no because they don't like some people at the school. Again, biases can be very present in surveys and people's opinions when they respond to surveys. Okay? What's another problem with survey? People lie. Okay? They don't tell the truth, right? Again, that's pretty self-explanatory. If we are running a survey of athletes about how much water they drink, and they want to look good for their coach, which we'll get into that in a second, they might say they drink more water than they do, right? And then we're going to get accurate results. So make sure the people that you're interviewing are reliable sources. Super opinionated people. I would call this the politics of Facebook, right? The people who are screaming for the extreme left politically or the extreme right politically often volunteer to respond to stuff on Facebook. Or think of it outside of politics. Think about an opinion poll on a radio show. No one who calls in for an opinion poll on a radio show, most people are not like really chill, relaxed people, like somewhere in the middle about the decision. They're super biased one way or the other. So you have to be careful when you're running a survey of having people volunteer to participate, because the people who volunteer might be the most extreme opinions. You also have to be careful of biased questions. I would look at the news on this, right? If I can bias a question to sound really good one way or really bad the other way. A way you could phrase it, let's say if I was asking you about what your favorite chip is. If I was saying, a non-biased way would be, what is your favorite chip? A super biased way, though, is, do you disagree with the opinion, or please give me a good reason why you would not agree with the opinion that Lay's are the superior chip. I'm kind of asking the same question, again, what's your favorite chip? But the second way is super biased. Now, are we going to see it presented that way in the real world? Not always. I really want to exaggerate it so you understand, but you get the idea. Watch out for bias in people's questions when they're writing a survey. And then finally, we've talked about this. I don't need to spend a ton of time here, but is an accurate sample being surveyed, right? And this goes back to, what are the problems with convenience surveying, right? If we don't get an accurate sample, like with the coyote example, our survey is not going to turn in good results. Another topic we can talk about here is hidden bias. Okay? even when we aren't deliberately vocalizing our bias because we're super opinionated or we have strong feelings one way or the other or anything like that, there could be some hidden bias here, right? If I, as a teacher, walk up to you and say, how's your math class going? There's a hidden bias there. You are going to be naturally inclined to tell me you're doing well, right? Because I'm a teacher, I'm a math teacher. You know I like math. You know I have control over grades. You want me to think you're doing well. Whereas if your, friend walks up to you and says, hey, how math class is going, you might, without knowing it, respond more honestly than you ever will to me. That's called a hidden bias. It's a bias where I really am not intentionally trying to bias you one way or the other, but your response is going to be different because of my position as a math teacher. Okay? And then lurking variables. What is a lurking variable? Well, a lurking variable is a variable that is causing a situation, but we don't realize it. Let me give you an example here. Let's say that Van Buren High School football. Obviously a little different this year, but let's think back to last year. Think about how many people went to the games. Now, let's say I walk in and go and study this, and I go, man, I really want to raise some money for our athletic department. How could we do that? Well, more people could come to the football games. Okay, so how do I go about that? Well, I noticed that Taylor Swift, a year ago, had a concert in Columbus. And she had thousands and thousands of people coming to her concerts. And then I looked at the ticket prices and said, man, the average ticket price for a Taylor Swift concert is like $70, and that's for back row seats. Some people are paying hundreds and hundreds of dollars. I go, well, guys, if we up the ticket prices for the Van Buren football game, we are going to see more results. We'll get more people in the stands. Duh, up the ticket prices. We're going to have higher attendance. No brainer. Now, you all are sitting at home behind your computer screen going, this guy's an idiot. What's he talking about? Obviously, upping the ticket price is going to make less people attend. What I'm alluding to here is what's called the lurking variable. What's the lurking variable in this case? The popularity of Taylor Swift, right? Popularity is probably the reason for both situations. It's why Taylor Swift gets a bunch of people to pay up high prices and a bunch of people go to her concert. And consequently, it's why Van Buren charges low prices and still maybe not a ton of people come. Because outside of Van Buren, Ohio, not a ton of people care about Van Buren football. Does this make sense? I hope it does. Let me know if a lurking variable doesn't make sense. Again, it's when you notice two coincidences happening. Again, higher ticket prices, higher attendance, low ticket prices, like at Van Buren football, low attendance. But really, there's a third variable here. In my example, the popularity. That's the reason for both situations, not just the coincidence. And finally, here we're going to look at overgeneralization. Okay, what do we mean by overgeneralizing? Well, if I overgeneralize here, let's say I do a study on drugs, okay? I study a drug and it helps rats run faster, okay? And I do this in a controlled environment in New York. Does this mean that wild horses out in Montana would also run faster if I gave them the drug? Absolutely not. That's a overgeneralization, right? Just because one thing did one thing for one group doesn't mean it's going to help another group of people. You can make some generalizations, right? Maybe out of my controlled lab, I go, because of my controlled lab experience, maybe what I did with the rats will help other rats. But going straight from rats to wild horses, that's an overgeneralization. As you can see at the bottom of the page here, page 25 has a ton of helpful resources for you. Okay, if you read that page, you're going to get more in-depth explanations of what I've explained here. There's also a cool guided exercise that will help you out as well. I hope this makes sense. I know I went through so many definitions. It's very dense. take some time here, go back through, jot down any questions you have or any definitions you're like, Mr. Carter, you did not make sense. That's totally fine. Go back and write those down, and then we'll talk about them in class. Thanks, guys.